Hello, today's lesson is identifying functions. We'll start with a warm-up there. Compare the slope of line segment KM and line segment PS. All right, so when we look at that, remember we're just talking about the slope of those. We're not trying to, we're not comparing the length of them. It's just the slope, and they're on the same line, so the slope is the exact same. Because if you look at the rise over the run, it's really small to tell, but the simplified, they would be exactly the same. So slope, because it's on the same line here, is the same slope. So we're looking for equal or same. A says less, that's not it. B says greater, that's not it. There it is, it's equal to. And then D is cannot be determined, that's not true. It can be. All right, let's move on. And so we've got a essential question, how to identify functional relationships. Today I am identifying functions using sets of ordered pairs, tables, mapping, and graphs so that I can determine if a relation is a function. I'll know I got it if I can analyze the data to identify a function. So a function is a relation. Remember, we did the relation lesson. The relation is a set of ordered pairs. But on a function, so it is a relation, which means it's a set of ordered pairs. But here's the part that makes it a function that gives a single output number for every valid input number. And just to simplify that, x values cannot be repeated. Okay, so it's a function if the x's do not repeat. So look at our table here as an example. This is a function. All of our input or x values are different. This is not a function. You can see the 4's repeat. All right, you cannot have any x's that repeat. They all have to be different in order for it to be a function. Okay, we actually had this slide yesterday, or the previous lesson. So function is a relation that gives a single output. We just talked about that. So again, there's different ways to represent the relations. It could be functions, graph, equation, table of values, set of ordered pairs, and mapping. So let's look at a couple of questions that see just to practice which set of ordered pairs represents a function. All right, so we're looking for the set that has all the x's are different. So we're looking, represents a function. This has 3, -4, 0, 0. The zeros repeat, so that's not a function. B, -5, -4, oh, the -5 repeats, not a function. 5, 2, -3, -1, all different. That's a function. And this one, let's see, the 2's repeat. So the answer is C here. Another one like that. Set of ordered pairs represents y as a function of x. Just a little worded a little differently, but same idea here. The x's cannot repeat. 2, 4, 6, 8. Who do we appreciate? That is a function. The next one, look, the 1's repeat, so that's not. Here, the 3's repeat and the 4's, so not a function. 1 repeats and the 2 repeats, not a function. So the answer here is A. All right, a little different format here. Now remember when we talked about relations, I said if this is difficult for you to see or analyze, you can write them as ordered pairs. Okay, so the -6 only goes to -8. That's good. 1 only goes to -8. That's fine. The y values can repeat. It's these that cannot repeat. You don't see it going to another thing. If it repeated, you would have another arrow thing coming off of it. So these are all single arrows. Again, these all have just one arrow going from it. so the x's don't repeat. But look at this one. It has the 2 on there. So that has 2 values for -8. So that is not a function. And then I don't know what the question, so this one says the relation is not a function. These are not worded correctly. Oh, right here. I don't know how they set this up. That's weird. So it's just A and B are the same thing. This is a function, and this is not a function. That's weird. That's a weird multiple choice question. So basically, again, these sets of data are the same. I didn't notice that before. The x's don't repeat. You just have one line coming off of those, and so that's a function. Here, sets of data the same. But you have 2 lines coming off of that, so it's not a function. Okay, let's go ahead and try one that's not a multiple choice question. It says the table shows the masses at m grams of different numbers of identical marbles. So there's the data listed. The number of marbles would be Rx. Mass of marbles would be Ry. Okay, so it's just giving you the data. Why is the relation also a function? We're going to just write the answer here. These don't repeat, so that's why. All the x values are different. So we'll just put x's don't, no x repeats, or however you want to word that. Second question there, identify the independent variable and the dependent. So the independent would be number of marbles. Okay, the weight depends on the number of marbles. So number of marbles is independent, and the dependent is the mass. Should have wrote that out on the other one, but is mass. Okay, practice writing the domain and range. So the domain, just going to write a D there, is you have 1, 2, 3, 4, 5, and 6. Range, you just list the numbers out. 1.27, 2.54, that is a terrible bracket there. Should have just done parentheses. 3.81, running out of room, I'm going to have to go down to my second line. 5.08, see that we're just listing the numbers. So nothing complicated there. Hopefully you understand that. Okay, let's go ahead and look at a graph to determine if this is a function or not. Okay, so let's think. We're going to go ahead. I'm going to write these as ordered pairs so you can see these values. This should have been done after our vertical line test, but I'm going to go do this first. So this point here is at, the x value is -1, and the y value is 3. This one, the x is also -1. So we're done. Those are on the, they have the same x value. So it's not a vertical, I mean, it's not a function. Now, next, we are going to talk about the vertical line test. So let me just show you on this one. If you put a vertical line, vertical means up and down, like you can take a pencil. If you put a vertical line, if it goes through more than one point, it's not a function. So here is the rule right here. So we've got our vertical line. Again, you can use a pencil. I'm going to do my best to draw a straight line without it being slanted. So we can move this, and you can see that it's only going to go through, the x values are all different. Here, the same thing, okay? All the x's are different. And here, none of it's not touching the x twice or more than once. So those are all examples of functions. All right, so let's look at this. So there's our vertical lines. It's not gonna, the x's don't repeat. So this is a function. So it passed the test. Here's a fail. Here's a vertical line. It hits the x twice. Has this x value here, whatever it is, or any of these points, like this one, it's the x has two y values, so that's not a function. So let's try a few. So we're gonna, on the graphs, let's just use the vertical line test. And right away, hopefully you see that that has two y values for this x value. So that's not a function. I'll just put not, or I'll just put no. So let's look at the next one. You got ordered pairs, -3, 2, 5, 2. The 2 repeats. So that's not a function. So that's no. I need to change that pen color. That's not coming out very well. So here, all of the x's just have one line coming from it. So yes, that is a function. We look here, the points, -3, 1, 2, 3, all different. So yes. This next one, oh wow, yeah, 4 different lines. No, not a function. All right, let's look at the table. Just look at our x values. Are they all different? -3, -2, -2. Nope, that repeats. So no, that is not a function. All right, so then we'll go ahead and do a couple more. Make sure you understand this. All right, so age and shoe size. Okay, so wow, your foot keeps growing when you're 45. I hope not. Actually, I'm older than that, but hopefully it stops, right? All right, Oliver is doing a study on age and shoe size. He has collected the data shown above. Do the ordered pairs x and y he has collected form a function? Okay, so age, 8, 9, 10, 8. Those repeat. This is not going to be a function. So no, no, no. So let's see what answer would be correct. Yes, obviously no, that's not it. No, because for some y's there are more than one x's. Okay, be careful with the way it's worded. This one's yes, so we're definitely going to cross off A and C. Let's look at D. That's also a no, because some x's have more than one y. That's what we're looking for. Remember, x's, think of the mapping, it has two lines coming from it. It has more than one y. This 8 has 7, this 8 has 9. So the answer is D. A little tricky on the way that one was worded. Okay, so this one was an actual star question. Which representation does not show y as a function of x? All my x's are different here. Okay, we can do the vertical line test for this one, and you can see that x's do not repeat. This one, you have 2, 3, 7, 11, all different. All right, D, look, you've got 2 lines coming from 3, so that repeats. 2 lines coming from 5, it repeats. So the answer is D. All right, lessons for the week. All right, we are here. There's no live classes on this day because we have professional development that we have to do as teachers. And then we have the rest of the week. Now there could be a quiz on your schedule, so please make sure if there is that you do complete that. Reach out to me if you have any questions.